through. I'll perhaps do it as a separate post rather than linking it to engine condition testing, but yeah, I've got it and I will post. Okay. I said, okay, then, like, you're going to answer back.
Yeah, that's fine.
I'm in the zone, that's what it is, yeah.
Testing. Right, again, sorry, just to drag this on, but I'm just saying to the YouTubers, this is at this point in the video now, we're recording the video, so we'll put it on YouTube from this point on, and welcome to those of you who watch after the event. So hopefully they'll be able to
well
the questions from that. Okay, cool. So we talked about the Zoom feature, thanks Steve.
Yeah.
That's great. In the video you mentioned a little bit about routine maintenance. Can you expand on possibilities?
Yeah, this was crankcase pressure was one of it. It's something that occurred to me, and I think I've seen it a lot in the US, where they'll take a signature of the crankcase pressure, exhaust gas pulsations and intake for that matter, but it tends to be as non-intrusive as it could possibly be. But you would capture, let's say at every service, intake manifold, crankcase pressure, exhaust gas pulsation, engine warm, maybe at 1,000 RPM and 2,000 RPM, and keep those as saved file signatures. Then the same again in 10,000 miles time or whatever it may be, every routine service. And hopefully start to detect or at least get early warning maybe that something's not right. If we start seeing a difference in pulsations that are uniform, that are changing between service intervals, maybe there's an indication of where somewhere. The one that springs to mind would be crankcase pulsation. So let's say there's a non-uniformity that was picked up initially, maybe not on the first service but the second service, but by the third and the fourth service that has certainly changed. I think it's a good way of giving your customer maybe additional confidence from the test you've carried out, and the confidence they're knowing that they are the engine's being monitored certainly at every maintenance opportunity. Maybe not routine maintenance every time the vehicle comes in to grab a signature of crankcase exhaust gas pulsation.
Yeah, certainly it's fairly intolerant, isn't it, to any sort of misfires, for example, and things like that.
Yeah. Misfires because of combustion, maybe ignition or injection, didn't really have any bearing on crankcase pressure. So it looked fairly robust at the bottom end, but if you do capture something in the crankcase, then that really is, or should set alarm bells ringing, because from the testing that we've done both with out the petrol, what was that like, Ben? Was it uniform?
Crankcase, yeah, very, very uniform. Yeah, absolutely. Yeah.
So in which case, anything that steps out of line with crankcase, we should be on that straight away. Yeah, certainly. So routine maintenance, signatures from crankcase pressure. Profiling.
Yeah.
Let me write it down. Profiling. Yeah.
Problem stakes?
Yeah.
Any more big words?
Predictive.
Predictive maintenance. Oh, that's stop.
Cool. So, so I mean, so you've highlighted there that the crankcase pressure is very much a test which, if you see an issue on it, then you know you've got real problems. Are there any of the other tests which you would say are a go-to test, for example?
With diagnosis or a go-to test, your first port of call, is it based on accessibility and probability? Is that what Frank says about
diagnostic process?
Diagnostic process, yeah. I've seen nothing wrong with a quick inspection of exhaust gas pulsations, purely because it's incredibly non-intrusive. I think it's the least intrusive test out of all of them. If you want to argue that taking the dipstick out of the dipstick tube is intrusive, but there seems to be a lot revealed in intake and exhaust from experience, So, which of those two? It depends. It's I guess down to accessibility, probability. You'll have an inkling, won't you, when a vehicle comes in, especially if you know your product. For those working on, for a specific brand. but then maybe a favoured test that you could do knowing your product like you do. If not, then it's part of sequence diagnosis, and it forms part of pressure analysis. If you've proven it's mechanical, then it needs to get intrusive, so that would be in cylinder. But if not, then okay, you've got these other avenues to explore, non-intrusive. Wow.
It's part of the background noise.
Yeah, pardon that. Yeah. Must be a visit.
Yeah. And again, guys, with regards to any questions, feel free to jump in there. With,
Thanks, Steve. Yeah, definitely relative compression and exhaust pulse is great. Non-intrusive first test, absolutely. Yeah. I think there's so much to be revealed from the relative compression, and from experience of supporting, it often gets overlooked. We're quite keen to believe that this is an electrical fault or it's going to be a really technical fault, and we forget that at the core of engine management is a mechanical unit, and dare I say it, stick my neck out here, mechanical is often the weakest link. It is, because management-wise and systems-wise, they tend to be very robust. You know, no manufacturer makes a bad vehicle; they can't afford to. But at the core of them is this mechanical unit that, if it's not maintained correctly, then reveals, or we can pick up issues, certainly from the relative compression test and your choice of pulsation test. Yeah.
Yeah. Well, that's a big statement there.
Oh, it was a bold one. Yeah. It's like saying that all vibration issues are wheel and tyre.
No. Let's leave NVH.
I stand by that. But anyway, yeah. The weakest link is mechanical. I'll probably have that written on my headstone.
Cool. Yeah.
Great.
I thought these guys spent a lot of time putting the video together. I had very little to do with it this time, but so one of the things that really stood out to me when I watched it was the effect of the EGR valve on the inlet manifold pressure.
Yeah.
That, albeit on a diesel vehicle, but that really bowled me over. What are your thoughts on that?
It surprised me how pronounced it was, but we have to remember what we had here was a 4-cylinder diesel engine, so that's a lot of compression, high compression ratio. So when you take one of those away, you probably saw it later in the video when we analysed all the waveforms together, just how that reduced crankshaft speed. I think losing one cylinder or having a misfire on one cylinder, we dropped by about 200 RPM. We were also missing that combustion event. So when that exhaust valve opened, the gas pressure and gas temperature was massively reduced, and you couldn't see that pulsation. And if you remember, it aligned perfectly with the exhaust valve open event for cylinder 4, which was the cylinder that we had the pressure transducer in. And I found that an incredible piece of diagnostic gold, because you didn't have to think about the time delay when you were measuring your exhaust gas pulsation. Because, you know, we had that disruption in the exhaust pulsation waveform that doesn't quite align with the exhaust stroke of cylinder 4, and that's because of where we are measuring. If you think about, we open the exhaust valve, there is no combustion gas there. That has a disruption in the manifold, of course, but then we're measuring at the tailpipe, so there's quite a delay. I think it was almost or beyond 180 degrees of crank rotation before we felt that anomaly at the tailpipe. So, measuring in the intake, we almost got 2 for the price of 1. We got exhaust pulsations and intake manifold pulsations in the intake manifold, but more importantly as well, right next to or closer to the combustion chamber than the pressure transducer in the tailpipe. So yeah, piece of gold, I think. Yeah, so, discovery on a diesel.
Yeah, on a diesel. So any thoughts on a petrol?
We need to measure that, because again, the pressure and just how aggressive EGR is with diesel was clearly seen in the intake manifold. I'm just wondering how that would have been seen on a petrol. I'm sure we have a capture somewhere, but I've never really analysed it to that depth. So it's perhaps something we should target and maybe put on the forum and compare the two. Yeah. Thanks, Bob.
I mean, it generated more work for everybody. I think it would have. It wasn't a feature on my car or on the petrol car that I used in the video, which is my car.
And yours is a direct injection.
It is GDI, yeah, and so with a lot of there's GDI particular filters coming out soon, I think, as well. So maybe EGR is going to be a part of that in the future for that particular type of engine. So I think it is something we
I think what we might do there is if we can find a petrol vehicle with that, and if we do something like an active test or force the EGR open, so we can almost correlate, perhaps use a channel for EGR position sensor, and we'll see that EGR goes from off to on, and then compare pulsations. We're able to see if we do it on the right speed time frame, we should see it all in one buffer, which would be quite nice. Yeah, like we captured in the video. So yeah. And we'll get that on the forum, definitely. Yeah. What's that? You can use a scope with a microphone to determine audio. Oh, right,
yeah. We need to speak up more. I think that's what Keith's actually alluding to. Slightly.
Yeah, that's a fair point, Keith. Yeah.
Sorry, guys, if it's quiet.
Yeah. We have maxed out all the levels, I can assure you.
It's because we're so softly spoken. That's what it is. That's what it is.
Yeah.
No comment.
Oh, okay.
So if obviously we're quite lucky here, we're surrounded by kit. If you're a technician in a workshop, how else could you, what other sensors could you use, do you think, to support their diagnostics, say if they've only got one WPS 500?
Yes, good point. The majority of the time we've got map sensor, of course, in intake manifold, so we could use that to back up your single use or the use of a single WPS pressure transducer. So we could have WPS in the exhaust, map sensor in the intake. It could be that, you might be able to get pressure pulsations from a DPF pressure sensor. Yeah, so there's another option. So that could give you exhaust. You could have map sensor for intake manifold pressure. You could have airflow as well, because pulsations in airflow will be picked up by the airflow meter. So that could be an option outside of measuring pressure. Hopefully saving you a pressure transducer for crankcase. Yeah, so that would get you those three covered. Yeah, so other options outside of pressure transducer.
I think on some Mazda diesels, actually, I've seen recently, they've actually already got a pressure sensor purely for exhaust pulsations already built in. So there is an opportunity there as well to apply some bit of software, you should be able to see the pulse from that. Yeah.
Of course, we're all going to get the sack tomorrow because the actual answer was to buy more WPS.
Exactly, yes, buy another one.
I was going to add to that, pressure transducers built into glow plugs. So basically,
no, stop now.
I think we're out of a job, really. No, that pressure transducer is an awesome bit of kit. I stand by that. I think that and a current clamp, awesome pieces of kit that certainly a current clamp we take for granted, don't we? But it is a great bit of kit, non-intrusive kit. And the case studies that we've resolved or been able to analyse using the pressure transducer, especially for valve timing issues, have been a godsend. I don't genuinely know how I managed for so many years without a pressure transducer. And I'm not saying that because I'm here working for Pico, not at all. I know how many times I've struggled not having a full understanding of what's going on in the cylinder at any given time. And a pressure transducer with the training would have put that to bed immediately. Yeah.
I remember first time I had one, he showed my dad, and he's from a different sort of different time zones altogether.
Time zone?
Yeah. Well, different century, or different dimension.
A different era.
Yeah. And he was absolutely blown away with the detail you can get, and he was very pleased I spent the money.
It actually brings me on to the case study. There's a case study on the Pico forum that we looked at. It was a 3-cylinder Golf that had, three-cylinder Polo, where the timing chain had skipped a number of teeth whilst it was in the workshop, which is the worst case scenario when something like that happens to you and the car is in your care. But long story short, based on the results that we got, having no compression, the vehicle had stood for a long time as well, post the fault. I was almost adamant that the cylinder head was coming off because of bent valves. I think this was one at Kevin Ives actually. And what we decided to do when we got this all built back up, rather than diving and whip the head off, let's just crank the engine with all the spark plugs out. We had a pressure transducer in one cylinder, that's it, that's correct. So we've got the engine cranking over at very high speed, or as high as we can get it on the cranking. And we noticed that compression started to build very slowly, and this capture is in the case study. And I think it was about a minute and a half of cranking, but you could see pressure starting to build, so we knew that our lack of compression was down to drain down of hydraulic tappets, which of course, as they started to prime from cranking, we could see compression building because valve correlation and valve activity started to become correct, if you like. The duration started to get to where they should be. And sure enough, that was enough evidence to think, right, let's get the plugs back in there. Now we've built compression and crank it out. Sure enough, this was on 3 cylinders because it was a 3-cylinder engine, that is, not because it was missing one. So yeah, using the pressure transducer stopped me jumping to the conclusion that we must have bent valves because we've got low compression. Yeah. I hope that made sense and that wasn't waffle, because it wasn't meant to be. Ben, you frantically look. Yeah, Ben's going to put the link up to this.
Just going back to a tiny bit, we had a nice bit of feedback from Steve Scott there again about the DPF, saying that works well. So thanks for that
thank you.
confirmation, Steve.
Yeah,
appreciate that. We have a question about exhaust leaks and how they can disturb the exhaust flow pattern that's achieved.
You know something, exhaust pressure pulsation analysis is a minefield, it really is. You're absolutely right that a leak in the exhaust system will affect your pulsation, as will a misfire, as will a compression issue, whether that's on the intake or the exhaust side, because they're all correlated. What got me thinking was exhaust system design, just how complex some of these performance exhaust systems are. Think of V configuration engine, 8 cylinders with multi-branch manifolds and crossovers flowing into one and then back into 2. Turbo configuration that removes some of the energy from the exhaust gases. Huge variables, and I guess the only way we can put them to bed is capture vehicles where we don't have a fault, so that when we do have a fault, we can see that there's a difference between the two vehicles. And maybe another technique is to introduce a fault. So introduce a misfire and see what happens to your exhaust gas pulsation, because you will have the advantage of knowing which cylinder was misfiring, because you've introduced the misfire, however you've done that, whether that be with ignition or injection. So that might give you the structure of the pulsations that you're measuring. You know how to interrupt those pulsations, so then restore the vehicle to as it was when it arrived in the workshop, and then look at the pattern. And again, not easy, but you're looking for that non-uniformity.
And thanks to Keith, who's also highlighted the issues with exhaust design. And
well, I think even actually something prior to the video that we looked at on the Mazda with the twin exhaust system. So it's a single pipe into a back box, which was then split out to 2. Weirdly, and I can't explain why, but every now and then it would actually, by blocking one side where you'd think that actually it would help improve the pulsation, it actually reduced it, and it actually made it less obvious. And one of the things that we kind of thought about was actually, by blocking one side, has that actually introduced another waveform or another pressure wave?
Another variable.
Another variable, yeah, exactly. So you guys are absolutely right. You know, exhaust design certainly plays a big part in the gas flow.
Yeah,
definitely.
I guess the waveform library comes in there, doesn't it? That if we can upload as many known good, then great. All the captures that I did here on the diesel, they're all on the waveform library now. So at least we'll have some signature waveforms there. I kept the ones with the faults in as well. Yeah. So we've got good and bad comparison. Yeah. So perhaps something we ought to do here as well. Maybe perhaps everything that comes in, we'll just get a signature and send it up to the cloud.
Yeah.
Wherever that is.
Wherever the cloud is.
Yeah. Actually, there's a good point there from Chris Groff. Sort of looking at the pressure pulses straighten off the pipes off the turbos, and I guess did a similar thing back along when wanted to be sure of the emissions pre-cat, and a drill and a nuts hurt set can go a long way to helping you.
Actually, I think I touched on that in the video about. There's an article on the forum or a post called "The Search for Overlap." And this is from Fat Freddy, who's posted on there. He's done a lot of study. I don't know how he got away with this, but I think he drilled multiple holes in the exhaust system of his wife's car. I don't know how he did it, but and he got away with it. He must have done it.
Yeah, he did well.
And sure enough, just looking at the variations in timings of these pulsations as you move down the exhaust system, and also how complex and how odd the pulsations are when you're measuring them in the exhaust manifold compared to the tailpipe, because obviously there has to be a change in the dynamics, and I'd imagine you'd sense overlap tremendously when you're measuring in the exhaust manifold.
Yes.
Yeah, because you're right, almost adjacent to the combustion chamber on a number of vehicles anyway. So.
Yeah, very much so.
There was another question up here, I think.
The search for, well done, you got that as well.
Yeah, it's all going on. I think there's been a couple of questions actually slightly away from WPS, but more about some of the other tests in Pico Diagnostics.
Which, to be fair, is non-invasive, but
yeah, exactly. It's not really part of it. I don't know if we want to discuss now or leave it to the end. Mainly, we'll carry on where we are.
We'll leave that one. So we've got possible electric vehicle testing.
Yeah.
This one's looking at Pico battery tests in Pico Diagnostics. Actually, that is something should highlight that in the video we used the relative compression guided test, but Pico Diagnostics also has a relative compression tool, which you can actually use to do a kind of absolute compression as well.
That's a great question from Jesper.
Yeah,
we got that one, Jesper, and I'll look at that as well.
48 volt systems, I think, let's not go too much depth at the moment, but it's certainly something that's going to be here to stay for a little while whilst we bridge that gap between full hybrid or full electric, I should say rather, and it's something we certainly need to be more conscious of, and we're going to be certainly looking into all of these systems.
So I just confirm that. So the question for our YouTube viewers is that Jesper is saying that on 48 volt Mercedes cars, they don't have a traditional starter, but a combined starter.
Starter generator.
So how do you do relative compression in that case? And so the guys are saying that's a good question, and definitely one we will follow up. Okay.
Yeah, exactly the same, Chris. Yeah, so we will follow them up.
Oh, yes,
we're on the test
there. There is. We could perhaps put the link in for that, or we'll do it later maybe. But in diagnostic. Diagnostic discussion, battery test results explained is
yes,
in there.
It is,
Okay.
That'll keep you busy for a little while.
I hope the forum posts help, guys, because the more I look around at what's posted on the forum, not from Pico's side, just guys helping one another. It's an incredible area to view and to read for training, or just-in-time training, or just building up your own knowledge base. I think it's a great place to park as much knowledge as you can, because you can't hold it all in your head. So being able to get it there, and for everyone to see, it's a wealth of there's a wealth of information there.
So top tip, if you want Steve's mind dumps, go to
yeah.
Tell you what, actually.
But no, thanks to anybody who posts on there as well. It's great, and I really wish we could all reply to every post. I really do, but it's impossible.
Yeah, a lot going on. Have we put a link out to the, or can we, for the pressure waveform overlay? That appeared to be quite a valuable tool.
Yes. Let's see if I can find it.
It's a pressure waveform overlay tool. That was the Microsoft pressure analysis software, which is on their own Microsoft store. The actual help file, that if you click on help within that software, it takes you to a YouTube video, and it pretty much guides you through the whole thing, video based, very, very easy on the eye. I mean, I was up and running with it fairly quickly, and it's fairly intuitive as well. You know, you can get around it. Yeah, pressure waveform overlays from Microsoft. Yeah, I quite like that overlay chart. If I had one criticism, I think the overlay chart was the colours were awful. But yeah, but Microsoft, it's very good. Thank you, Microsoft.
So we've had Keith has mentioned a case study on a newer Audi design that could not have been diagnosed without
Hans Jorgensen, yeah.
Yeah, is that one we've?
No, that's one from another member. I think it's from Hans Jorgensen. Did a brilliant case study on a newer Audi design. Could have been could not have been diagnosed. Oh, God, spit the words out.
Yeah.
Yeah.
Ah, cheers, Keith. Brilliant.
Yeah, thanks, Keith.
Yeah, lovely.
Oh, okay. What's that? The SSP for?
Let's find out, shall we?
Yeah.
Oh wow. Okay.
2 litre TFSI
TFSI.
with ABS. Okay.
That's brilliant.
ABS is
I think it's just
further development.
Oh, so it's then G code, is it, rather than?
No, I think is ABS some form of variable valve system, is it?
Audi valve lift system
Oh, okay.
on exhaust camshaft only.
Right. Okay.
That's a great piece of information. Thank you, Keith.
Thank you, guys. Thank you. Yeah.
That's right up on Diagnostics.
Yeah.
That's a great tip. Thanks, Keith. Yeah.
Steve Scott there, is that originally from Rod Mayers? It's very, very similar, Steve. It's now, well, it's from the Microsoft store. I'm not sure if there's a connection there with Rod and what's on the Microsoft store. I don't know. But yeah, CWV is Compression Waveform Viewer from Rod Mayers. That's a great piece of software as well. Don't know where it's available from though. So,
Yeah.
Sorry, something that was mentioned about variable valve lift. Yeah, like there's not enough variables when you're doing pressure analysis. It's critical to understand the engine that you're working on, and can you prevent these systems from operating or inhibit them. And coming back to the diesel, inhibiting EGR enabled us to just concentrate on intake pulsation. Inhibiting variable valve timing during pressure analysis, that might be relevant as well, because a measurement you take at one point in time may be completely different to another because of intervention of maybe variable valve lift or variable valve timing.
Yes. So you've had that conversation with some manufacturers who've said that all sorts of tricks go on at cranking. And
yeah. Ben's SkyActiv 2 litre petrol has a very clever compression event. I think for the first 10 seconds of engine running, the compression is high. Is that
high?
correct?
Yeah, it's really high as well. Yeah, to be honest with you, I can't remember the figures off the top of my head.
It's dramatically high compared, and then after 10 seconds, the exhaust note changes and compression has dropped.
Yeah.
So it's doing something elaborate with valve timing during that first 10 seconds. And I think during it has a plug cleaning event as well.
That was what we were thinking, wasn't it?
Yeah. During a relative compression, whether it has something in its logic that it feels as though it's got a foul spark plug, it runs through a very elaborate, it almost minimises compression, so the engine spins really fast as though to clear fuel. We noticed it
One
during
of the yeah, because
compression.
we was going to add a relative compression test in the video as a non-intrusive test. We came to actually run it, and there was nothing there. It was like there was no compression on the engine. Slightly panicked because I was wondering how I was getting home. But yeah,
I didn't panic at all.
Did you not?
No,
you was giving me a lift.
Okay.
Yeah, so I think being mindful of the systems that you're working on, how they work, and as Steve said, being able to minimise the effects that certain systems have is key.
Yeah, take away the variable.
Yeah.
Another one is the variable valve lift on one of the Toyota Auris engine, I think it was, the 1.8. There is a point in time where that vehicle will be at idle speed, but the throttle is wide open because air is controlled by valve lift only. So if you were to do a intake manifold pressure pulsation test with a WPS pressure transducer at a certain temperature, you'll have some wonderful pulsations because the throttle's closed. But it could be that minutes later, as the engine temperatures increase, the throttle's moved to full open, you're at atmospheric virtually in the intake manifold, and you're not getting the pulsations because intake is being controlled by variable valve lift only. So yeah, again, be aware. Know what you're working on. And it's not always easy if you're working on a multitude of vehicles, multitude of brands, sorry.
Yes, BMW.
Yes, yeah. Thank you, Keith. Yeah, that's a typical example.
Yeah, it's like the same as the Valvetronic where it's controlled on the valves. That's a very, BMW is a good case where their intake manifold is going to be doing quite different things.
Yes,
With Valvetronic. That's,
I think the introduction of swirl as well, the effects of swirl flaps on intake manifold pulsation. Not so much pressure, but if we're looking for pulsations to reveal something about how the vehicle's running, we need to know how the systems operate and how they could interrupt or confuse us when we're looking at the final measurement.
Whilst you guys are there, if you think of anything that you think we've missed in this presentation or in the video as well as now, then please raise it. And we had some great feedback during our last practical Pico on the CAN bus testing, where we all learned something about the termination resistors.
Yes, thanks for that information, because again, we live and learn together, and that was a journey for me, because I sat here and I said, I'll answer that on the forum, but I had to research the answer, research the question before I could give an answer. But now that opens your eyes, like a lot of these things, and trying to keep up with the variations between manufacturer is just
hard work,
challenging.
So if we can share back, anything that you guys, we're happy to follow up on anything like that. We are talking. Well, it's funny, we just start off talking about something which seems so at the heart of motor mechanics and mechanical system, and we've seen just how the complexity just spirals, if you like, in the modern systems. From what is a fairly simple concept of
exactly. Exactly.
Nothing is simple.
And I think, Keith, you've mentioned it beautifully there, the Fiat multi-air engine.
Oh, yes.
Oh.
Yeah, is that the 2-cylinder with solenoid
That's
intake,
it,
is it?
Yeah. What a minefield that is. I've never had the pleasure, unfortunately, or fortunately.
What a lovely challenge, I think, don't you mean?
No. Yes, that's right. Yeah, what a lovely challenge from Fiat.
Ben has just accepted that challenge.
No, I don't think I've had.
Thank you very much, Ben.
Great.
Next question. I'm actually going to write it on the pad.
I think there's actually some Fiat waveforms on the waveform library from the multi-air.
Okay.
I believe. Don't hold me to that.
Pressure.
Keith, come on down, I've got plenty. Yeah, I'm sure. Is there a reason for that? I'm sure there's some on the waveform library. It is very unique. I think that's the most diplomatic way of putting it.
I feel your pain, Keith, I feel your pain.
And another example might be the EcoBoosts. Does that do strange things as well?
EcoBoost? I'm not sure it does an awful lot.
Nothing too strange.
No.
What other examples? We've covered BMW. Anything else you guys think we should research? Let's say we've Fiat is a good one.
Yeah.
BMW.
Yeah, I like the multi-air. I do. I think
Yeah.
that's great. We could really look at the relationship between solenoid and cylinder pressure. And again, if they're changing conditions while you're trying to test them as well. Yeah. Again, this is that thing about know your product, if you like, or know what you're working on, and can you inhibit these changes? Can you stop them from occurring? So at least you can get consistent diagnosis.
Mm.
Yeah.
Mm.
So that's the multi-air. Okay.
Yeah.
Yeah.
I think just to talk about the pressure transducer itself, really, and that is, I don't really know whether I picked up on this, but it is USB rechargeable, so it's a 5-volt recharge. Not to use it whilst you're charging. There may be a temptation to, because the device's low battery indication is on, but you've got to use it. Your time is money, I realise that. You may have noise generated whilst you're charging it, so just be aware of that. With that said, I've managed to use a power bank. So if you've got one of these power banks for your mobile phone, something like that, it's a get out of jail, because if you're working in the field and it's caught you out, low battery voltage on the pressure transducer, then charge it via power bank. Charge time, proper charge time is about 2 hours on the WPS, and standby time, that varies. If ever we're doing training or demonstrating with it, 6 hours is not unusual. I'm normally conscious about switching it on and off between presentations, let's say, or if we're discussing the results from one measurement, perhaps switch it off and then back on again for the next measurement. But it's certainly during training, it doesn't give issues, and that's a day normally. That's certainly a day. And I think finally the peak temperature, on the back of the pressure transducer, it talks about the peak temperature being 60 degrees. And that is the housing, the measurement port, if you like. Now, 60 degrees comes around pretty quick if you're looking at diesel compression, if you're looking at coolant systems, or
fuel pressure.
Fuel pressure on the
return system.
Maybe on the returns, 60 is high. Automatic transmission fluid, that was another one. But the battery is the concern with WPS. That's why we want to keep temperature down, but the battery is also well protected. It's mounted on a heat sink and it's away from the measurement chamber. So whilst you may see 60 degrees on there and think that this is not for you because you'll be using it at higher temperatures, I've used it way beyond that, certainly on diesel compression. That's the one where I've actually held the device and it was very hot. So it caught me out. But no issues there. I have not had one yet turn off because of high temperature. Not yet.
Oh look, there's a request for it to be a
high pressure
sensor.
Okay, yeah.
Get asked that a lot, don't we?
Yeah, WPS equivalent.
Yeah.
Common rail, I know.
Yeah, Hans, the WPS 600 is only for hydraulic use. Please don't try and attempt to fix this into a common rail diesel system. This 600 bar is pretty high in terms of mobile hydraulics, but I think fuel rails get much higher, and it just wouldn't be safe to use in that situation. Would we ever make one? I think it's difficult. I've worked for a number of different manufacturers where removing the rail pressure sensor is actually prohibited. They don't recommend it, and once you've removed it, you can't do anything else but replace the whole rail. I think if you can qualify that the sensor is good and working okay, then actually why not just use that?
Yeah.
It kind of makes sense to me. That way you're being as unintrusive as possible.
Yeah.
I know there is products out there where you can actually interrupt that, and exactly, Chris. Yeah. Sorry, Keith. Yeah, removing anything means replace. Yeah. So I think, whilst it seems like a really nice idea to have, I struggle to see where I'd fit that as an application, if
And yeah, so like I say, you roll out the pressure sensor, and then you can look at what's happening on the valves and what the ECU is trying to do to those, and if it's trying to compensate one way or another. So you can see whether the ECU thinks it's got the pressure it has got or not, and so on, and how it's responding. So there are ways around using a actual WPS on there anyway. So
Yeah.
it's,
I think there's always been an inherent fear about interrupting a common rail system, and I know we do it day in, day out. We take pipes off, injectors out.
do you see?
Well, yes, we do. We do. We used to.
We used to.
And I think there's the contamination issue, isn't there? I don't have any. In the heat of diagnosis, you've got to do what you've got to do, and let's be honest. In the real world, WPS 600 is not the tool for that. I'm not going to dig myself into a hole anymore. That's the official line.
That is the line. Yeah.
But when it's all you've got, it's all you've got. Unless next question.
Yeah, Chris has handily pointed out some reasonably large pressures.
Yeah, 16,000 psi there.
Yeah.
Wow. Yeah, it's quite something, isn't it? Yeah.
And I'm sure those that know Chris and the type of vehicles that he works on, they're not to be messed about with.
Yeah. Yeah. I think the pressure, the fluids that WPS has not been tested with. So this is coming back to WPS 500. From what we know, brake fluid has not been tested with WPS, and refrigerant gas is the other one. So whilst we've experimented, because that's what we can do, it's possible, of course, to read pressures, but the device, the seals within there, I think it's Viton seals, have not been tested with those two items. So, and I'm sure there may well be other fluids it hasn't been tested with. I will look into that now I've said it, but certainly I know those two haven't. Yet, air conditioning pressures via WPS is awesome to see. And to be able to graph them against other things like cooling fan operation and compressor operation, it's great. Yeah.
But we've never done that. We've never done that.
Stop digging, Steve. Stop digging.
Moving on.
Guys, we've got. What time are we due to finish
well,
this? I'm just looking at the time because I think last time it just ended abruptly and we went,
yeah,
that's the end, and never really sort of closed. So we just want to make sure that we're not going to run over again.
Thanks, Ben. Excellent point. In terms of again, please get in touch via the forum or call, or often we will be answering questions on YouTube if we can. But get in touch with us if you've got any other questions. If there's anything else you would like us to sort of raise or look into, then so we'd only be too happy to help there. We have got further practical Pico events planned for the remainder of the year. Hopefully things which you'll find quite exciting. I know we're quite
We're
excited. So please keep watching. If you want to take what you've learned today a little bit further, then this is mainly a plug for our UK audience, unless you want to travel over to the UK and get training. But if you want to take things further, then there are training providers throughout the UK, thinking of the likes of James Dillon, Frank Massey, Andy Crook, and so on. Lots of great guys out there. I'm sure these guys could mention loads more.
Sorry, Gary. There's great guys in the field, all of those. And technicians training technicians, that's great to see. Yeah, certainly sharing the knowledge and helping one another, because that's what it's all about. Keith, you've mentioned something there, that's great. I'd like to see a temperature probe within the WPS 500, and that makes perfect sense, doesn't it, to be able to measure temperature of the fluid, because we know that pressure changes with temperature. So, take that on board, and we'll put as a new feature request, so I will feed that through into the system, definitely.
Let's see how non-ideal gases react in cylinder. Brilliant. Yes, Yes, so we've got our thermodynamics course planned for next week.
This again, the complexities of in-cylinder pressure analysis. I mean, that's one cylinder on its own, and then you can take many more. But just talking about compression and peak compression and the numerous variables there are when you're measuring peak pressure in a cylinder is just mind-blowing, especially dynamic.
6-week lesson on partial differentiation for you guys.
New feature, temperature,
Cool.
sensor in WPS. Very good. Thank you for that.
I think also, guys. I mean, you know, I know we said we're set for the rest of the year in terms of what you guys would find useful from us in terms of these practical Pico sessions. But if you've got some ideas about what you'd like to see, then definitely. Please let us know. We've got some ideas, but they might not actually be of any use to anybody. So it's you guys that are out there that are, seeing the faults, seeing the problems. How can we make your life easier? Is what we're all about, really. So if you have got suggestions, please send them.
Yeah, absolutely. More feedback, the better. Thanks, guys.
And to challenge them as well, because we are. Looking back on this pressure analysis, I kind of went on a bit of a journey trying to explain why events happened, and if anybody disagrees or has a different explanation, it's always good to hear that. And that's why I think where the forum really works, that we challenge one another, and it's good to be challenged. It's right to be challenged because
that's how we learn.
And I may not have got it right. It may not be right. So
Cool. Okay, guys. So. I don't see any direct questions there, so I think we will wrap it up before we're forced to wrap it up. Just want to thank you ever so much for joining us and for contributing. I know quite a lot of people would like to watch without contributing. Next time, don't be shy. Please jump in anytime. But thanks from us. We really appreciate your time.
Yeah.
Thank you, guys. Thank you very much.
Brilliant.
All right.